Alright, let's do this quick exercise. And the reason it's quick is that I'm going to sort of push off most of the work to you. Because, here, we're going to use this fact. We know from combinatorics that if we're given m and l in n, which is all integers greater than or equal to 1, then the number of L tuples of integers, non-negative integers, but more explicitly integers greater than or equal to 0, whose sum is n, is given by m plus l minus 1 choose m. And this is a combinatorics fact that, like, I don't know, I'll be honest, I really do not like combinatorics, so I don't want to go through the proof of how this works or why it works. But I looked it up on Wikipedia, and it's true. And there's apparently some sort of stars and bars method of proving this, and you can go look that up if you want. But I'm just going to appeal to it here. So I guess that's the real key to this exercise, is that you need to know this fact. And if you don't know it, then I don't know. But anyways, so you should look at this thing and be like, oh, that looks really familiar. That looks like exactly what we're trying to prove. Except, here I should have written it differently. The number of m tuples of integers whose sum is L is given by L. So we could write this as, instead of L plus m plus L minus 1. Just to make it look... Oh wait, no, it was right the first way. So L plus m... No! Okay, m plus L minus 1, choose L. Okay. We also know that sim LV should be an L, has basis given by VM Rm, where each Ri is greater than or equal to 0, and the sum from 1 to m of the Ri's equals L. Which we can see has size. Well, how many things are in here? This is, each of these is given, each element in the spaces is given by the order of the VI's doesn't matter, because this is the symmetric product. And so these are possible combinations of, let's see here, you've got m tuples of integers. So you can associate this, any basis element, with the m tuple R1 through Rm, and we know that each Ri is an integer greater than or equal to 0, and the sum is L. And so we appeal, it's exactly what this combinatorics statement gives us. And so by that fact, it has size m plus L minus 1 over L. And that's how you prove it. So if you know this fact about combinatorics, then the solution is immediate. And if you don't know this fact from combinatorics, then you can just pretend like you know it anyways and just appeal to it, because you know that someone has taken the time to think about it. So you know you don't have to take the time to understand what's going on if you trust that someone else has. Of course, that's not how math is supposed to work, but that's how I'm going to do it this time, because I don't want to think about combinatorics because I don't like it. But anyways, once you know this fact, The proof is pretty straightforward, and so here it is.